Starting where we left off, we want to take a look in the x direction now. In the x direction, I'm going to have two forces. The first force is the force of the motor, and the second force is the force of air resistance. When I want to set up information in the x direction, I'm simply going to say that my net force in the x is going to equal the force of the motor minus the air resistance. The reason why I'm subtracting air resistance, that I called that the negative value, is because that's hindering the progress of our air balloon. That's why we try to say that whichever direction we predict it's going to go is positive, and whichever direction that we predict is opposite of that would be our negative. It's hindering and not helping. The helping force is going to be our positive value. So I have that set up. Now again, when I go through, I cannot say that force net in the x is 0 because we are going to have acceleration. We were not told that this was a stationary hot air balloon. So I'm going to say mass times the acceleration in the x direction is going to equal the force of my motor, which is 1520 newtons, minus the force of air resistance, which is 950 newtons. I'm going to substitute in my known value for mass, which is simply the 413.27 kilograms, and do the subtraction to get 570 newtons. When I go through and solve, I find that my acceleration in the x direction is simply 1.38 meters per second squared. Since there was absolutely no acceleration in the y direction, I can say that my total acceleration is going to equal the 1.38 meters per second squared. Like I said, this isn't too far off of what we've already done. Take a look at and read through the next problem, and then we'll get started on what happens in an elevator.